Woohoo! Quiz 1 is over. Now we're on to quiz 2. So let's practice. Here's some stuff. Okay, so if you want to know if a piecewise function is continuous, you have to consider a few things. You have to see, does the limit exist? That means, well, actually, let's do first. Does the function value exist? So in this case, f of 0, does that exist? Is the limit as x approaches 0 from the left equal to the limit as x approaches 0 from the right? And does the function value equal the limit? So if I look at this function, if I want to find f of 0, I can go up here and say yes. Do you see where it says x is less than or equal to 0? If this equal sign wasn't there, or down here, not so much. But here I can say cosine of 0, and I know cosine of 0 exists. And the way that I figured this out is I would do this and make a cosine curve. That's a terrible one, but we get this. Cosine of 0 is 1. So I say, yes, the function value exists. Now I'm going on to, is the limit, oh, now you can see it. Is the limit as x approaches 0 from the left equal from the limit as x approaches 0 from the right? From the left, I can see x is less than 0, so less than or equal to 0. So from the left, I can see it's just cosine of 0, which we already said was 1. From the right, I need to go down to this part. So I can say x cubed plus 1, so 1 cubed plus 1. Oh no, 1 cubed is 1 plus 1 is 2. So sad. So I'm going to say no, and I don't even need to bother checking the third one. Okay, so that's the first type. This is pretty similar. But I want to know, is this one continuous? Is this function continuous at 4? So for 4, the same thing has to be true. So does the function value exist? I'm going to try that first. So the function value at 4, there are people in the back of the room laughing in this video. I know that you guys think it's awesome, so it's totally okay. They want you to do really well in this quiz too.
Yeah!
You can do it! Yes, see, told you. They're saying positive things. Okay, so f of 4. This is how you make friends, by the way. You make cool videos and put them on the internet. F of 4, I can see x is less than or equal to 4, so I'm using this part of the function, x cubed plus 1. So I say 4 cubed plus 1. 4 cubed would be 4 times 4 is 16 times 4 is 64 plus 1. I get 65. Great. Now I'm going to check, does the limit exist? So the limit as x approaches 4 from the left. Does that equal the limit as x approaches 4 from the right? Oh, you can't see that very well. There you can. Okay, 4 from the left. I would go up here and I see 0 to 4, so I know x 3.99, somewhere around there. I would have x cubed plus 1, which I already found out was 65. 4 from the right, it would be down here from 4 to 7, so I'd say 5 minus 4. Oh no, 65 doesn't equal 5 minus 4, so sad. Not continuous. The next one. Is this function continuous at x equals 7? So I would try f of 7 to see if the function value is defined. I can see up here there's a less than or equal sign, so that's good. So I have 5 minus 7 is equal to negative 2. Now I check the limit from the left. Is it equal to the limit from the right? And I can see the limit as x approaches 7 from the left would be from 4 to 7, so I'm looking at this part of the function. So I get 5 minus 7, which is negative 2. I want to check, is that equal to the limit as x approaches 7 from the right, which would be down here. Negative 2 times 7 plus 2. Oh no, negative 14 plus 2 is not negative 2. So still no. I know, and by this point, you're really hoping that something is continuous. Hold on, maybe it'll be this one. Maybe not, because I can see, is this function continuous at 7? At x equals 7, I need to see, does this function exist? Oh no, it doesn't have an equal sign to it, so no. Okay, but let's say if it did. Let's say if I change this problem, and it said 4 is less than x is less than or equal to 7. Then if I tried this one, 5 minus 7 is negative 2, so f of 7, sorry, f of 7 would be, if I made this up and I said that this is now equal to 5 minus 7 is negative 2. The limit from the left, I would use this part of the function. So 5 minus 7, I get negative 2, which I already set up here. Negative 2 times 7 is negative 14 plus 12. Hey, look, it's negative 2. So just by me changing this little symbol, super important, so make sure you're paying attention to details. And, you know, you'll be awesome. I'm not saying you already are, because you're awesome. Okay, the next one, true or false. So this one, limit as x approaches a. This is the function g of x. Limit as x approaches a, it's saying that it's equal to 1. In order for a limit to be true, remember the limit as x approaches a from the left of g of x, I started writing f, has to be equal to the limit as x approaches a from the right of g of x. So I'm going to go for a. From the left, I can see that it's approaching 1. From the right, negative 1. Ah, they're not the same. 1 does not equal negative 1, so this would be false. This limit does not exist. Okay, this one, limit as x approaches b. So b is right here. Remember, limit as x approaches b from the left has to equal the limit as x approaches b from the right. So if I do that, I'm approaching b. I don't care that this function value is up here. All I care about is limits. So don't worry about the function. I care about the left. I can see it's approaching 1 from the right. Also approaching 1. So, yeah, this would be true. Does this limit exist? Remember, all I care about is the left and the right. So if I say the limit is x approaches a of f of x, which, by the way, I don't like this graph because it should be labeled, but I made it up, so, you know, I can change it. Limit as x approaches a from the left has to equal the limit as x approaches a from the right. It does, so yes, it exists. Similarly, limit as x approaches a. This one is filled in. There's nothing weird going on. Left equals the right. I don't care that this function is continuous. All I care is the left equals the right, but it does, so this limit also exists. This limit, the limit as x approaches a. Do you see how from the left? Sorry, I started writing infinity. A from the left, f of x. This would be going to positive infinity from the right. It's positive infinity. So I could say the limit as x approaches a is going to infinity, which would be true, but infinity is not a number. So is not a number. That's terrible notation. We should just say no, this limit doesn't exist because it's approaching infinity, and infinity is not a number. Okay, the next one. Does this limit exist? I'm not going to write this out this time, but the left has to equal the right. The limit from the left is up here somewhere. The limit from the right is down here. I'm going to say nope. The limit does not exist. Okay, these are everyone's favorite. So the limit as x approaches 0 of 1 minus cosine of x over x. There is some stuff that you know. Remember, the limit as x approaches 0, and one of them was sine of x over x, and you get 1. And you could say sine of cx over cx, and you could get 1. Or the limit as x approaches 0, 1 minus cosine of x. And this is 0. I don't know, might be your answer right now, but it shouldn't be a good answer on the test. So, you know, I won't make it a choice. This is the other kind. This is where I just said sine of cx, like any number. Oh, sorry, my bad. Cx, limit is x approaches 0. This is 1. It's just one of those things you have to remember. Eventually we're going to get to another way that you can do this. 1, that seems like an important part for you to see. Okay, so this one has sine of cx over cx, kind of, but there's a 4x here and there's a 2x here, and that's no good. So what you need to do is separate this fraction into something that I can take the limit of. So the limit as x approaches 0. What I'm going to do is separate this fraction. Remember, you can do this as long as you have common denominators. So this is totally acceptable for me to do. And if I do this, and I'm taking the limit as x approaches 0 of all of this mess, what I can do is I can separate it and say limit as x approaches 0, and I can say of 8x over 2x plus the limit as x approaches 0 of sine of 4x over 2x. Okay, so this one, 8x over 2x, x's go away, 8 divided by 2, this limit is just going to be 4. Plus, over here, it's almost what I want to happen, but sine of 4x over 2x, is that quite right? But if I had 2 times 2, that would now give me 4x, but I can't just multiply the denominator without doing something to the top. So I'm going to multiply that by 2. Now I can see this part, this limit is 1, but I still have this 2 hanging around, so I'm going to say 2 times 1. 4 plus 2 times 1, 6. This limit is 6. Okay, next one. This limit as x approaches infinity. Right here, I have an exponential function. So in this exponential function, you have to remember that exponential functions look like this. They either go like that, they go like that, or they could be flipped the opposite way. So somewhere there's going to be a horizontal asymptote, and the other, like the limit as x approaches infinity or negative infinity, it's going to go off forever into infinity or negative infinity. So as x approaches infinity, I'm going to choose a really, really, really big positive number. Let's say 100,000. I could add some more zeros. It doesn't actually matter. So I'm going to say 3/4. When I put in a really big number into here, it suddenly makes it negative. And I know it says plus 5, but I made this number up anyway, so let me just make up 100,005. Or I'm sorry, yeah, that would work instead. And I can still do this. Plus 4. If I have a negative exponent, what that means is I can flip my fraction. Now make my exponent positive. If I have this 4/3 is 1 1/3, so it's over 1. So if I take 1 1/3 times 1 1/3 times 1 1/3 times 1 1/3, it's going to make a huge number. And if I add 4 to a huge number, I'm still going to get infinity. You're almost done. Don't go away. Okay. This one, if the limit exists at a. So what this is saying, if a limit exists at a, all I care about is the left is equal to the right. Right? The left equals the right. That's it. What do we know about f of a? I don't know that the limit is equal to the function value. It could be if you have a function that kind of looks like that. Here's a. The function value is equal to the left and the right. But I don't know this in this problem, so I don't know this. Limit as x approaches a from the left or the right. Again, I don't know this. So it looks like this should not be the answer, but I know absolutely nothing about f of a. If I said something about the function being continuous, then I would know the limit as x approaches a equals f of a. But for right now, if the limit exists, I know absolutely nothing about f of a. Okay, this one, the limit as x approaches 2. Here's f of x, here's g of x. You're using both of them. Limit as x approaches 2 of f of x. I'm going to do that one first. And because I can separate this and say the limit as x approaches 2 of f of x and the limit as x approaches 2 of 4 g of x. So here, limit as x approaches 2 of f of x, 2. All I care about is the left is equal to the right. They're not going to the same place. So right now, this limit does not exist. It doesn't matter what this one is, but if I have does not exist here, I can't possibly add it to a number. It would still be does not exist. Okay, this one. Find a value of a such that the limit as x approaches 4 of f of x exists. So this one is a little bit more complicated, so you should be thinking different part of the test, not maybe multiple choice. But either way, you do what you want. You don't, I don't own you. See where the limit as x approaches pi over 4 from the left equals limit as x approaches pi over 4 from the right. If you are asked to justify anything, this is a very, very important step. Make sure you don't miss that part. So then I would say, okay, well, this would be a tangent, and I'm putting in pi over 4. And then from the right, I would say 2 times pi over 4. So take a second and actually figure that one out. If you're doing tangent of pi over 4, I would make a triangle. Be like, okay, well, here's pi over 4, pi over 4. This is a right isosceles triangle going way back to geometry. I would have 1, 1. Pythagorean theorem would say 1 plus 1, or 1 squared plus 1 squared is 2. Then you would have square root of 2. Tangent of pi over 4 would be opposite over adjacent. So that's a times 1. 2 times pi over 4 would be the same as pi over 2. A times 1 is just a. Ta-da! We have an answer of pi over 2. Next one. So going back to this, is f of x continuous? For a function to be continuous, remember the function value it has to exist, the limit has to exist, or the left has to equal the right, and the function value has to equal the limit. Right away, if I just check f of pi over 4, do you see how it's not equal to one another? So I can say this one, big old nope, because there's never a place where x is less than or equal to pi over 4. I can't ever put pi over 4 into this function in any place. So at pi over 4, there's going to be a hole of some sort. Let's say I change this, and now I had a problem like that. Then I could do some more work. Then I would have to say, okay, the function value at pi over 4, figure that out. Then I would have to check the limit as x approaches pi over 4 from the left. Find out to see if that's equal to the limit as x approaches pi over 4 from the right. And then make sure this value equal that one, see if the function is continuous.